Hi, this is Micah Mitchell with Madison County Weather Updates. I'm going to do the long-awaited winter weather forecast. I've actually had video done for a couple of days, and things have gotten in the way of being able to post it. Yesterday, I got stuck in the voting line for 5.5 hours. Didn't see that coming, so I didn't get it uploaded. But the last video had some errors in it anyway, not errors, but I was having to clear my throat a lot. And so I thought, well, why not just go ahead and do it over and see if I can make it a little more concise this time anyway. Just as a reminder, the website is coming. I know I've been saying it for a while, but we're really close. We've had some issues, and I think everything's all ironed out, and Jordan is in the process of getting the thing going. So hopefully we have that going here in a few. So in the meantime, we do still need donations in order to keep this page going, keep things going the way we've been doing, and hopefully even make it even better. But as it stands, I have about $50 or $60 a month in costs that I'm putting out in order to make all this happen. And I've since have added web hosting and such. So we do still need your donations. You can see the link information up there. You can send it via PayPal to andersoninwx@gmail.com. Again, the website will have some options for you to make one-time donations or set up monthly donations where you don't even have to think about it anymore. I would love to continue to bring this to you and maybe even do better and do some value-added things for the county as well. So hopefully this will get going. The website will be going here very shortly. Again, I've been saying that for a couple of months. We'll see how it goes. In the meantime, here's the winter weather forecast. Things I want to touch on right off the bat is, seasonal forecasts, but especially winter weather forecasts, are an educated guess at best. It's a little easier to nail down the summer because things tend to be a little more stable than what they do in the winter. In the winter time, there are always dozens of pattern drivers, but again, they're more stable in the summertime, more volatile in the winter, and all it takes is one or two of them to change to make or break a winter, or for just one of them to change in a big way to make or break winter. And of course, when it comes to individual storms, I see I have a typo up there. When it comes to individual storms, you can have a perfect setup. We've seen this the last couple of winters. You can have a storm that seems like it has a perfect setup, and something changes, something in the mid-levels usually, that you really can't see until it's happening. And something changes and it busts the storm. And there have been a couple of times over the last winters, I can think of the end of December 2013 and I think the end of December of 2018. Both times we had not even a cold front, just some front of Genesis set up on an axis between Anderson and Crawfordsville in both cases. And on nights where we should have gotten an inch of snow, we got 6 inches of snow. So the right things happening in a bad setup can make for a big snow. The wrong things happening in a great setup can make for a bad snow. So that's always a crapshoot just with an individual storm. Then you go throwing that into a seasonal forecast, and it really makes it sketchy. I touched on the forecast soundings in the winter preview, but I want to touch on it just real quickly again, just because let me get my pointer on here. Again, this right here, what I didn't have last month that I do now, is a snow sounding in this little area right here, about 2,000 feet thick. That's where snowflakes are made, in a 10-mile thick column of air. 2,000 feet of it, sometimes 3,000 feet, makes your snowflakes. So all it takes is something to go wrong in that little dendritic growth zone, and it ruins your snow. And again, that's just for an individual storm. And you go trying to predict how that thin layer is going to work out over the course of a winter. It's kind of a crapshoot. And again, here's an ice sounding. Again, your dendritic growth zone in this particular storm was 3,000 feet. And it's still just a small parcel out of over almost 16 kilometers thick air parcel. But you can see warm air was getting into this, and it was a pretty thick parcel of warm air. It was close enough to the surface before it went back below freezing, so this would fall as freezing rain. You'd have your snow, it'd fall through this zone, turn completely to liquid, then doesn't have enough time between where it drops back to freezing and the surface to refreeze, so it falls as freezing rain. It freezes on contact, and you've got an icy mess. If this warm parcel is thinner and is at the bottom of it's higher up, then it has time to refreeze and it falls as ice pellets and you get sleet. So again, that's just showing you kind of why forecasting winter precipitation is so difficult just for an individual storm, let alone an entire season. I'm not going to get back into these. I kind of addressed them in the winter preview, but it's just showing some of the literally probably 2 to 3 dozen pattern drivers that affect winter weather, affect our weather all the time, but especially in the winter time. There are a handful of these that are usually at play, but there are some others that are not on this list, like the Indian Ocean Dipole and some others that also affect winter. Here is the so-called typical La Nina setup. We are in a La Nina. We are now into a strong La Nina. We're kind of borderline moderate to strong. No doubt we're heading completely into strong, but this is just typical. And what you have is a polar jet stream will go up and over high pressure that sets up typically in the western Gulf of Alaska. You'll get your Aleutian low pressure out in here. The jet stream will go up, grab some Arctic air, then drop down the east side of the Rocky Mountains. A lot of times, if you can get your big snowstorms, you'll get a system tracking along the Pacific jet also. And if you can get those to phase back out in here, you get a big storm that then drops in, gives us a good snow before moving out through the northeast. If you don't get phasing, sometimes this will, the trough will move back and forth, and sometimes you get a clipper. Sometimes we can still get on the upside of this and get a good snow. Also in typical La Nina, you get a pretty strong southeast ridge. So sometimes we get rainstorms, sometimes we get snowstorms. The best snowstorms we get usually start off as rain and become snow. So this is just a typical La Nina. However, and I'll address it as we get into sea surface temperatures, I believe this high pressure is actually going to be centered more over here. The southeast ridge isn't going to be quite as dominant, and I think it's most of the time going to be a little bit farther up the east coast, which will have the effect of squeezing this trough a little bit, allowing it to get a little bit deeper and putting us more on the upslope of it. That's what I'm thinking is going to happen. So we'll move on. Nino 3 and 4, this is the region that we usually watch how the waters are acting, because this has the most direct effect on the U.S. And when it's cold, it tends to cut off the subtropical jet, which can sometimes it can work to our benefit, but most of the time when the subtropical jet is really cranking up like it has last couple of winters, it really introduces a lot of warm risk. We won't have that. It'll perk up at times during a La Nina. Was going just about a week or so ago to just a small, weekly, but it was there. But most of the time that kind of gets choked off, and that's what leads to the, Southwest, like California, being pretty dry in the winter, so, in La Nina winters. Here's what the sea surface temperatures, the absolute temperatures, looked like back in when I did the previous update, the winter preview. This is what they looked like on September 26th. This is what they look like on October 27th. I did most of this presentation back at the end of October. I just haven't had a chance to update it or upload it. So some of this will be from back then. I've added a couple of newer slides, but you can see over the course of the month, back September, October, The only real changes, have been occurring in the North Pacific where the water is cooled. That's to be expected. And of course, as the winter goes on, then these waters down here in the southern hemisphere will begin to warm up as they enter their summer, their spring and summer. So, but across the Pacific Basin, really the waters have continued to run in the upper 70s to the mid 80s. It's in the mid 80s back out here, maybe even upper 80s. Here you can see the cooler nose of water that comes with the easterly winds driving cooler water. It kind of upwells along the west coast of South America, gets caught in the easterlies and gets driven out into the Central Pacific. And that's helps form our La Nina. So I always like to deal with absolute temperatures at first. And also up here in the Arctic, when you see sea surface temperature anomalies, this up here will all be red, but you can actually see that temperatures are now at freezing or below freezing in the Arctic Ocean. So we have low sea ice extent, but that'll begin to fill in as we get into the winter time. Here's what we were looking at back in September. Sea surface temperature anomalies is where how they are relative to normal. And of course, La Nina was well established even back then. The thing that's kind of different in this La Nina is all the warm water. And what we were watching to see is, would this area continue to warm? Would this area continue to cool? If that occurs, that bodes well if you want snow. We were kind of also watching this area off of the East Coast, and whether it was going to warm or cool, and this area up here off of Greenland. This up here can help set up a Greenland block at times if it continued to warm. Well, here's what's happened. The Aleutians have in fact cooled over the last month. The East Pacific has warmed. In fact, the warming is moving toward the coast, which goes into my thinking that the high pressure that's typically more out here in a La Nina is actually going to be a lot closer to the East Coast. We've got warming waters over here, which is part of why I think the southeast ridge is going to tend to want to migrate up the East Coast a little more this winter. And again, and you see the cold anomalies over the Hudson Bay, because even though we're not getting a good Arctic connection, we don't need an Arctic connection to have a good winter. We just need a North Canadian connection. I think we're going to have that. There is cold air up there. Even when it's warmer than average up there, it's still cold. Cold enough to give us snow. Of course, that all modifies as it comes south, but it's still cold enough to give us snow at times. So with these features right here, again, I'm thinking that ridge that would normally expand across will actually be squeezed. It'll be able to get a little deeper, and then we'll be on the upslope of the of that trough when they do happen. And if we get well-timed storms, they could be some decent storms this winter, unlike the last few. Down here is just showing what Nino 3.4 has been doing, and you can see it's been on a steady. It kind of slowly cooled over the summer, and now it's really dropped off, so that at the beginning of November we're into the moderate to strong La Nina phase. This is a little more what you'd expect to see in a La Nina. You can see the warmer waters out in here, and which would promote the higher pressure being out in here. This was from 2007. I just picked this out because it's a little more representative of what most La Ninas look like. And usually we'll have cooler waters off of the west coast. That's not the case this year. So I just wanted to show you what La Nina normally, typically, so it looks like. There's no such thing really as typical or normal. With weather, climate, anything, there's no such thing as normal. So here are the sea surface anomalies, or sea ice extent, I should say. Again, this was back and what we posted a month ago. This over here is where it is now, and you can see it's beginning to expand, especially along the northern parts of Alaska. This will help give us some cool air supply when the jet stream manages to pull up into Alaska and then drop down into Canada. And what we're really kind of watching is what goes on over here in the Barents and Bering Seas. Those waters of been staying pretty warm. If that can continue and you can build up some high pressure and some lift over there, then as the polar vortex right now, it's kind of in a process where it's migrating around the Arctic Circle. But as the winter progresses, it'll tighten up closer to the Arctic Circle. And if we can get some pushing from along this area over here, northwest of Scandinavia, or just north of Siberia, where it can push on that, we can get some lift over here, push on the polar vortex and kind of squeeze it down this way. I'm not sure we're going to see any kind of a split of the polar vortex this winter. And I'm not sure how brutal of cold snaps we'll see. Usually we're good for one, maybe two. And yeah, that'll probably happen. Even in our warmer winters, we usually will have one or two pretty cold snaps where we have, lows in the single digits, maybe a little below zero, highs in the teens. That's probably going to happen almost any winter. Not always, but most winters, even warm ones. But hopefully, if you want snow, hopefully we can get some nudging over the course of the winter to push on the polar vortex and at least displace it south a little bit. That gives us a little bit better access to some colder air and helps out with snow. A lot of this so far is tracking pretty close to what 2012 was doing, although I think we're going to end up a little different than 2012, but so far it's tracking pretty similar. And that 2012-13 winter was actually a pretty decent winter for us. And this is just a look at on a graph. The blue line is Arctic sea ice extent. It's at a record low for this time of year since they've been keeping track of it in the late 70s. And, I'm sure some of the periods in the 30s the sea ice extent was lower, but since they've been tracking it in the late 70s, we're at a record low right now. That will begin to pick up. Over here, you can see the trend over the last few years has been below the mean since 1981. The mean is up here, and we've been running the last few winters below the, really outside of the margin for error. Here's a look at La Niñas since 2000 or since 1950. The ones in blue are ones where the La Nina peaked in the November, December, January time frame, which is about where La Nina is going to peak this year, and then it'll start to relax some. And so you can see that we had some good winters. 1950 it was 32 inches. We've had some average winters like 62, 63. It was 21 inches. We've had some garbage winters like 1970 and 71 and 1972, where we picked up 10, 11, 12 inches of snow. So we've had some bad winters in these setups too, but we've had some really good ones. So it's just kind of a mixed bag. I addressed the PDO the last time. I've added a couple of other winters as I went through more records. Again, the PDO is a kind of a hot button thing for a lot of people. Some people think that the La Ninas or that the PDOs. Sorry about the dinging. Getting some notifications. Sorry about that. At any rate, some people don't think PDO makes any difference. Some people give the PDO a lot of weight. To me, as I've looked at data, what matters with the PDO or Pacific Decadal Oscillation. Again, decadal is why there's sometimes not a lot of weight given to it because it's over such a long span, but winters are so short. But to me, what I see making a difference is whether the PDO is in transition from one state to the next. Is it going from negative to positive, positive to negative? Is it just staying positive? Is it just staying negative? And what we can see here is a lot of our bigger winters have happened when it was going from negative to positive. I mean, you can see there's 7 of them right there. We've had some where it was going positive to negative, which seemed to be the case this year, although I'm not so sure it's not going to stabilize. We've had one good winter where it was completely positive. That was 2002, 2003. We were in a weak El Nino that year. And then we've had some good winters where it was just strictly negative, which some people think that you can't get a good winter in a negative PDO. That's just not the case because, again, there are so many other drivers at play. But, what you'll see on the good forecast, good winter side is predominantly La Ninas, or on the kind of light blue equals means it's on the La Nina side of neutral. And the biggest, a couple of our biggest winters, our biggest winter that we've had, 77, 78, and we were going negative to positive, and we were in a weak El Nino. So El Nino doesn't always mean everything, but you can see predominantly La Ninas have led to some of our better winters. And some of our worst winters, we had strong El Ninos. I mean, you see it down this side, regardless of the PDO state, the strength of El Nino seems to make more of a difference. QBO, another quasi-biennial oscillation. I've done it since 1970. And again, you can see when it's in transitions from negative to positive, we've had some good winters. Positive to negative, we've had 3 good winters. All positive, 3 good winters. All negative, 5 good winters. So there's not a real trend there. Again, you can see La Nina seems to be the bigger factor in the decent winters. Same with the negative winters where we've had less than 15 inches of snow. Our most garbage winter was 72, 73, but we were in a strong El Nino. We only got 4.5 inches of snow in Anderson that year. At 97, 98, we only got 3.9 inches of snow in Anderson that winter. Again, strong El Nino. So, again, the ENSO seems to be the more dominant factor, and it probably will be this year. But some of these other drivers do factor in, and to me, it's more whether it's in transition than whether it's in just a solid state. Here's a composite of just what, this from the Climate Prediction Center, just what the typical December through February temperatures run during La Ninas, during typical La Ninas. Same way with precipitation, we tend to be a little bit on the wetter side. I think this year we're going to see the wetter anomalies a little farther southeast than typical. And snow, it really doesn't tend to make a huge difference in Indiana. We're generally kind of a wash, although you can see there's some positive anomalies. But, you get down to Tennessee, they don't normally get a lot of snow anyway, so it doesn't take a lot to make a positive anomaly there. The Northwest and Northeast are what tend to benefit the most during La Ninas. And this is just another pattern or a composite for all La Ninas. Again, Indiana, really kind of a wash. And this is for strong La Ninas, which is where we're headed. And you see a little bit of a positive anomaly up here in northern Indiana, less down in southern Indiana. Here's now getting into what others are forecasting. This is the CFS V2. It's got a torch all 3 months of the winter, and of course it has winter as a torch. CFS tends to favor blowtorch. I don't put much merit into this. If anything, I think the torch month is going to be in January, not in December. Here's the outlook from Weather Underground. They at least kind of follow somewhat my thinking, with some cooler air in December, January torch. They stay above average in February. I think we're going to bounce back closer to average, maybe slightly below for February. And then I really think as winter will be over by the second week of March. Here's a look at AccuWeather. I actually don't totally disagree with their temperature idea, but I think they're way too far north with the low snow anomalies. But, for the sake of information, they have, our area would probably be in the right around 75% of normal. Normal for us, or average for us, over the last 30 years is 18 inches. So they would have us picking up 14 or 15 inches of snow this winter. I don't think that's right. but I don't really argue with their temperatures too much. Here's the Climate Prediction Center. Yeah, remember where you are, because when I say this, I actually don't really disagree with them too much on this. I normally don't dig the Climate Prediction Center's forecasts too much, but I really don't think they're wrong. Again, on the temperatures being, the anomalies being pushed more to the southeast. This is just, CPC just does a percent chance of being above or below average. It's not a strength of temperature. They've actually got most of Indiana an equal chance of being warm or cool. I don't disagree with that, and they've got to 33% starting in southern Indiana. They've got us in above average, and I actually kind of agree with the orientation of the above average. I think it's going to fit in with the storm track that I think we're likely to see it for most of the winter. Now, of course, this is going to decide it wants to freeze. Okay, sorry, I had a little bit of computer problem there. I decided I wanted to freeze. So, moving on, I put on some tropical tracks because they kind of are showing what my thoughts are on what to expect with the Southeast Ridge. And these tracks were from Hurricane Zeta, and you can see, the storm actually ended up following more along the western edge of this. But you see the hard turn that it takes, and that a couple of the other tropical systems that have come through Louisiana have taken, where they make that hard turn. It's because the Southeast Ridge has really been more suppressed down in here versus making a big push up here. The white line is where I believe Laura went. I can't believe I didn't label it, but I'm pretty sure that was Laura. I added that in. And you can see that it actually came up and tracked through southern Indiana. I think that's going to be the northern extent of how, when the Southeast Ridge really asserts itself, I think is going to be in January. That's where I would think that it's going to assert itself a little farther north, like the way it was when Laura went through. But most of December and February, I think it's going to be more suppressed southeast. There's a type of storm tracks we're kind of expecting. Clipper tracks, pretty much the same almost every winter. Sometimes they're farther north, sometimes they're farther south. Panhandle hooks, I don't think we're really going to be seeing a whole lot of that because we're not getting anything really coming along the southern jet stream. Colorado lows is where our action is likely going to come from. These lows will drop down the eastern side of the Rockies, really get their act together in Colorado, and then track out in the shaded areas where I think, you can see I've got it taking a hard turn. That's what I think some of our storms are going to do when the Southeast Ridge is more up in here, up along the eastern seaboard, or along the Carolina coast, really. I think that's going to force these to take a little harder turn. At times where the Southeast Ridge is more down here, it'll allow these to just go ahead and track on off to the east. And whether they take a harder turn up in here somewhere will depend on whether we can get any kind of a Greenland block or not. That's kind of sketchy. I think we'll see it a couple of times, but not a lot this winter. But this is just kind of somewhat where I would expect storm tracks to turn. I think in this red dotted area here is kind of I-70 and south is where I think the bigger threats for warmth overrunning some of these storms and maybe giving some ice or sleet, or being the kind of storms like what we had last winter where it looks promising and we end up just getting a bunch of rain. That's what happened to us last year. I think that kind of action is going to stay south of I-70 this year. So getting into our forecast. Here's where I see the winter as a whole. You can see I'm not that different from the Climate Prediction Center, really. I'm a little bit farther northwest than they are. I'm farther southeast than most of the forecasts are. I really think that over the course of December, January, February, for Madison County, we're going to run a degree or two warmer than average, but I think a lot of that's going to be on the strength of January, because I think December is going to be up and down, but I think we'll have more cool times than warm in December. I think warmth in December is going to come ahead of storm systems and then cold in behind them. I, I think we're going to have decent chances for snow in December, not so much in January, and then again in February. Snowfall, I've got, again, I think the areas where we could really get some overrunning would be down here in the southern part of the state, south of I-70. But I think most of Indiana is still going to run, 125 to 175% of average. So for Madison County, I'll get to those numbers here in just a minute, actually. And I think, these areas up in here are going to see, well above average snowfall, and as they're going to be able to tap into the cold a little bit better and kind of fluff those snows up. And then southern Indiana, I think again, kind of a battleground, average to slightly below average. But they, one big snowstorm down there could totally wipe that out and give them an above average winter. So that's the risk of this. One or two big snowfalls really cranks this up. If we fail to get any big snowfalls, they can drop it down. That's always a risk. So for us, the 125, I've kind of addressed most of these points. So I'll just drop down the 125 to 175% of average. Our average winter snowfall over the last 30 years is 18 inches. So that would put us at 24 to 31 inches for the winter. And I think that's pretty reasonable. Again, I think that's mostly going to happen in December and February, maybe some early March. January, if we get a big, decent snow in January, it's going to be probably a stroke of luck. And, that could always, then boost our totals. I'm counting on not much in January, kind of like what happened last year where we got a half inch of snow in January. So that's where we are for the winter forecast. I hope you find this informative. I hope you enjoy what we're doing and will support us continuing on and being able to do even more for you as the website gets going. So for now, this is Micah Mitchell with Madison County Weather Updates. Thank every one of the 12,000 or so of you that follow us across 3 platforms. I'm very flattered and very appreciative of you. Thank you very much.